started from famous debate in ecology from 50s about density-dependent factors. Till 80s there was still debate, and still there was many ecologists were saying that everything in ecology is density-dependent, and many schools were defining the density-independent, it means abiotic factor driven. But this is one of the propositions by myself and Robert Nyman, who is trying to say that both guys are right. It means because in reality exists continuum of ecosystem from those one which, like in Greenland River, extremely abiotically regulated, there is no chance for competition predation, up to the Amazonas, where just competition predation is major driving force, and because hydrology is oscillating in very predictable pattern for 1,000 years. And obviously, many ecosystems between, and model is trying to show how it's dependent on the size of the river, stream order, and how it's dependent on temperature. This was a model which was used by FAO as a framework for program habitat modification of freshwater fishery over 20 years. A second story, which is related to the soil degradation. To start to reverse soil degradation, we have to understand what is the role of water temperature. And I think that major factor, water availability, determine carbon accumulation by ecosystem. However, the type of carbon is dependent on temperature, because in boreal zone, we have carbon mostly in organic matter, and biomass is not too much. In tropical zone, we have mostly carbon in biomass and not too much in the dead zone. Why? Because the rate of decomposition in high temperature is 40 times faster than in boreal zone. So obviously, condition when the ecosystem accumulate lots of carbon, the side 40 times faster recirculated by great opportunity for diversification of pathways, energy flow, nutrients flow, and obviously opportunities for highest biodiversity and bioproductivity. This obviously will be still dependent a little bit on geomorphology, because soil is this determinant to great extent for productivity, and in this model is assumed if similar, let's say, geomorphological potential exists. And there was the two models that were a kind of deductive. It means based on general theory, background of ecohydrology, but on every, let's say, theory also should have inductive. It means empirical background. And the idea about that system can be regulated. It means water can be, for example, regulated to regulate biota. Water can be used. Hydrology can be used to regulate biota. Was just started from this experiment in the beginning of 80s. I had the opportunity with my two colleagues, Professor Frankiewicz and Gorda Rywinska, to do research on energy flow through the fish communities along the reservoirs. And we were lucky that in 83 of the spring, the water level was very low and unstable, and riparian zone was not covered. In this moment, the fish were not having spawning ground access, as success of reproduction was low, 4 specimens per square meter on the view. And as a fact, zooplankton all July, August was very high, almost 20 milligrams per liter. This is yellow, July, August. And this zooplankton very nicely controlled the phytoplankton, and despite load of phosphorus quite significant, there was no algal blooms. And another situation was 84, when in the spring the water was maintained high and stable. Fish had a good access to spawning ground, and emergence was 40 specimens per square meter, 10 times more. They completely eat zooplankton in July, August, no zooplankton, and all phosphorus was in this moment transferred to the phytoplankton pool. So we had a situation, there was no zooplankton, high algal bloom, and what is interesting, because there was no zooplankton, fishes didn't grow up. And next year there was no recruitment. What was interesting, because zooplankton was eliminated, also predator was eliminated for several years, because predators, main bike perch, need to grow to 4 centimeters to go to piscivority, they need zooplankton. So there was a depletion of zooplankton, bike perch was starving, and in this moment we lost top-down control for many years. So that's why, you know, regulating next the process, and it was tested now even 20 years after. Dr. Isidorczyk was testing last year, and she achieved reduction by 50% predicted from the model reduction of blooms. So instead of, let's say, 17 milligrams of algae, she by just regulation water was reduced to 8. Obviously, this is only supportive measure. Why? Because weak point of this is that if flood is coming, it's destroying all interaction which we build up precisely on the base quantification process. So that's why still the stream maker should not say, okay, let's forget about sewage treatment plant and other measures. We can just manipulate water level and relax. No, this is only kind of support up to the moment, giving a little bit time to do the measures and upgrade the services for society. So now we're in ecohydrology already, so that's why general key point of theory is dual regulation. It means hydrology can be used to regulate biota, biota can be used to regulate hydrology, and this is called dual regulation. Second element, harmonization. Just to regulate hydrology in basin scale in different elements of landscape, we need to harmonize with hydrotechnical infrastructure. Let's don't destroy the hydrotechnical infrastructure. Why? Because if we modify the landscape, we modify cycle, hydrotechnical infrastructure is very often very necessary to compensate. Otherwise, the stochasticity will be too high, there is no chance to regulate. Obviously, we must understand the dynamic processes and eventually this harmonize with really ecological, by basin scale performance. Last one, integration. Various types of regulation has to be put in synergistic ways to stabilize and improve water resources, ecosystem, and so on. So now I will go to the examples how we are step by step implementing these ideas. I have to underline that that's what I'm introducing. There is a results effort of the big international team. There's many aspects which were just colleagues from UNESCO program participating and developing, and obviously coastal zone ecohydrology. First paper appeared here by Alexandra Chicharo, who first demonstrated what I theoretically was trying to predict, saying that ecohydrology always must cover from molecular to landscape scale, and first paper about the molecular aspect of ecohydrology is done by Alexandra. So now we're coming to the, I would say the ecohydrology has two phases, terrestrial phase and aquatic phase, because methodology will be different. Here we'll have a water plant soil interaction, so we have some knowledge which is from these disciplines, and aquatic processes are to a great extent depend on knowledge of hydrologists, ecologists, limnologists, and so on. However, obviously it has to be all the knowledge put it together. So what happens in the landscape? I just select few cases and I'm showing the one element. If we remember that 50% of fertilizer from here can be in water, that's obviously such a patches of land where there is no buffering zone are dramatically supplying the river for nutrients. And effect in case of Baltic Sea is seen here. The size of circle is loads from different countries. Obviously Poland is bigger country in Baltic Sea, biggest population, almost 40 millions. So in this moment we have a bigger load, and here is natural background. It means phosphorus from the leaves, branches, insects, and so on. Here is point source pollution, and this is from landscape. So now we see that if in all Europe all the attention is put to build sewage treatment plant, yes, we need them because simply pathogens elimination. Yeah? There has to be. However, it is impossible to improve the situation in coastal zones, in reservoirs, if we will not develop the systemic solution based on low-cost, high technologies, it means understanding the processes, for landscape, because this is critical. Obviously, a country like Finland, you see, the natural background is very high because population is just very few million in relation to our space. So such country have 70% of forests instead of 70% of agriculture. They don't have to worry, but it's not too much such countries in Europe. So now let's try to organize thinking, because working so long with FAO, UNESCO, I have seen in many countries that depends on specialization. Every specialist starting the action from different side. One guy from window, another guy from door. And very often leads to the wasting of resources, and any action in the scale of the basin is extremely expensive. That's why principles has to rather try like provide a certain framework for action. So first, hydrological is quantification of process is absolutely obvious for hydrologists. However, using GIS technique, work to put identify major area of non-point source pollution, point source pollution, eventually retention of water, some other size. And here is example concerning water quality. We had that in framework of a German program, identification nitrogen sources, and we see that, for example, this area of catchment has no problem with nitrogen, the impact is minimum, and we don't need to do any action. But in this dark brown, there are areas where really some measures has to be taken. What measures I will show just for a moment. Second aspect, more related to let's say, quantity. This is from Dr. Kedzi, my PhD student, Dr. Kedziska, former work. She evaluated the trapping capacity for phosphorus, the Pilica River flood, mainly about reservoirs, and possibility of increase the absorbing capacity by floodplain to reduce the impact of phosphorus to the river. This is published in Ecological Engineering for somebody is interested. So second principle is this harmonization, different measures like denitrification, transformation in biomass, self-purification, acceleration, and biofiltration. And I will not go this time to the details. We will go to the details tomorrow during Erasmus Mundus lecture. However, I would like to underline that lots of developments has always been based on the basic science. Because as a matter of fact, some technologies which I will show right now are just started from these findings. So these findings are showing, for example, in central Poland, the major factor which determines biomass of fish and biomass of invertebrates is calcium concentration in the river. Why calcium? Because in Margalef's paper I found the information that he says that calcium is beautifully trapping the phosphorus and providing to paraphyton, and that's why atom of phosphorus is, instead of traveling long distance, is immediately supplying, so spiral is getting very short, and this is very nicely showing process. I found also such phenomenon in Massif Central in France and some other places. So, but I will show how we use for development. Another story. This is against the classic paradigm of river ecology, that river is open ecosystems, everything depends on allochthonous matter. We found that, for example, light is major determinant of the productivity and biodiversity, and intermediate complexity of ecotones is stimulate highest fish biodiversity, productivity, and all cascade.